Scientists have recently made a groundbreaking discovery that has the potential to rewrite what we know about the cosmos. This incredible find, located at the very center of ancient cosmic structures, reveals something both astonishing and terrifying hidden deep within a black hole. This discovery is so profound that it challenges much of what we thought we understood about these mysterious celestial bodies. Prepare yourself, as we are about to delve into the fascinating secrets contained within the core of a black hole. If you're someone who enjoys keeping up with the latest news and findings from a universe and its vast, enigmatic surroundings, you may want to subscribe to our channel. By doing so, you'll ensure that you're always up to date on the latest scientific discoveries. Don't forget to like this video, share it to help spread the word, and turn on notifications to stay informed. The subject of black holes is one of the most captivating phenomena in modern science. First theorized by the brilliant physicist Albert Einstein, black holes were an integral part of his revolutionary theory of general relativity. In this groundbreaking theory, Einstein proposed that the gravity on the surface of a black hole is so intense that even light, the fastest thing we know of, cannot escape its pull. This insight flipped our understanding of gravity on its head. Unlike other forces we encounter, like magnetism or push and pull, gravity isn't a traditional force that acts in a linear fashion. Instead, it is a result of the warping or bending of space and time itself, a concept known as spacetime curvature. Gravity arises from the way objects with mass and energy distort the very fabric of spacetime. Imagine spacetime as a vast, flexible sheet. A massive object, like a star, causes that sheet to bend around it. The heavier the object, the more pronounced the curve, and the more intense its gravitational pull. In the case of black holes, which are some of the most extreme objects in the universe, the mass and energy they contain are beyond comprehension, causing the spacetime around them to warp to such a degree that not even light can escape their pull. The deeper the warp, the stronger the gravitational force. This is the key to understanding why black holes are so powerful and fascinating. Let's take a closer look at black holes themselves. They are among the most extreme entities in the known universe, containing an unfathomable amount of mass and energy concentrated into a very small space. The gravitational field of a black hole is so intense that it creates a deep depression, a kind of sinkhole, in the fabric of space and time. This is where things begin to defy our everyday experiences and truly enter the realm of the extraordinary. The gravitational pull near a black hole is so strong that it forms what scientists call an event horizon. The event horizon is not a physical barrier, like a wall or a boundary line, but rather an invisible region where the curvature of space becomes so severe that nothing, not even light, can escape. Once something crosses this threshold, whether it's a spacecraft, a star, or a beam of light, it is trapped forever, unable to return. This region has been described as the point of no return, where the normal rules of the universe no longer apply. The event horizon essentially acts as a cosmic one-way street. Once you go in, there's no coming back. This leads to another mind-bending concept. Light itself, which travels at a staggering speed of approximately 300,000 kilometers per second, is unable to escape the gravitational pull of a black hole. This is no small feat. Light is the fastest known entity in the universe, and yet, when faced with the intense gravitational forces near a black hole, even it is pulled in and trapped. To put this into perspective, if you found yourself inside a black hole, the speed required to escape would need to be faster than the speed of light, a feat that is currently impossible according to the laws of physics as we know them. At the heart of every black hole is a region known as the singularity, a point where the laws of physics as we understand them completely break down. The singularity is where all the mass and energy of the black hole, no matter how immense, is crushed into a space so small that it defies comprehension. The singularity is often described as an infinitely dense point with infinite curvature in spacetime. This means that all the conventional rules that govern the behavior of matter and energy in the universe no longer apply. The gravitational force here is so extreme that it warps spacetime to an unimaginable degree. It is at this point that our understanding of the universe collapses, leaving us with more questions than answers. What exactly happens at the singularity? How do the laws of physics operate, or fail to operate, in such extreme conditions? Despite these questions, scientists continue to push the boundaries of knowledge, exploring the mysteries of black holes and singularities in hopes of one day unraveling the secrets that lie within. To truly understand how black holes form, we must go back to the life cycle of a massive star. These stars are, in their own right, extraordinary cosmic powerhouses. They are fueled by nuclear fusion reactions taking place in their cores, where hydrogen atoms are converted into helium through intense collisions. This process releases enormous amounts of energy, which is what allows the star to shine. As long as a star has enough hydrogen to sustain this fusion process, it can maintain its brightness and stability. However, stars are voracious consumers of fuel, and once the hydrogen in their core is depleted, they turn to heavier elements such as helium, carbon, and oxygen. Each fusion reaction with these heavier elements produces progressively less energy. As a result, the star must burn faster and hotter in an effort to maintain equilibrium. Yet there comes a point when the star can no longer sustain these reactions. When this happens, the star collapses under the immense weight of its own gravity, triggering a cataclysmic implosion. This collapse marks the birth of a black hole, with the star's core compressing into a singularity. Recently, for the first time ever, scientists have been able to direct their state-of-the-art telescopes into the interior of a supermassive black hole located in the core of a galaxy some 800 million light-years away. Black holes are known for their insatiable appetite, devouring anything that ventures too close. In this particular instance, the black hole consumed matter, heating it to such extreme temperatures that it glowed with a radiant energy. This matter, in the form of superheated gas, created what is known as a corona, a glowing halo around the black hole. The temperatures reached millions of degrees, and the resulting X-ray flares, like cosmic fireworks, were released into space. What makes this discovery even more remarkable is that these X-ray flares did not simply vanish into the abyss of the black hole, as one might expect. Instead, they experienced what scientists describe as a cosmic bounce. The flares reflected off the gas behind the black hole, an area that defies the normal laws of physics. Incredibly, these flares survived the immense gravitational and magnetic fields surrounding the black hole. The black hole's intense gravity bent the path of the X-rays, allowing them to travel along a curved trajectory that ultimately reached our telescopes here on Earth. This discovery marks the first direct observation of light escaping from within the grasp of a black hole, a phenomenon that had only been theorized before. It's another confirmation of Albert Einstein's theory of general relativity, which predicted that light could be bent by gravity. This observation not only confirms Einstein's theory, but also serves as a testament to the brilliance of his insights into the workings of the universe. The story behind this revolutionary discovery centers on two highly advanced space telescopes, the XMM Newton, operated by the European Space Agency, and NASA's James Webb Space Telescope. These powerful telescopes focused on a supermassive black hole and observed a spectacular display of X-ray flares over several days. As the data was analyzed more closely, researchers noticed something curious. Some of the X-ray flares had different colors and arrived later than others, raising questions about their origin and behavior. After further investigation, it was revealed that these delayed X-ray signals originated from within the black hole itself, an unprecedented observation. The scientists then embarked on an exhaustive analysis, using complex cosmic equations to piece together the mystery. The phenomenon they observed is known as light echo. This occurs when light waves are scattered or reflected, creating echoes that can be detected even after the initial event has passed. In the case of a black hole, these light echoes were produced by the superheated material spiraling around the black hole, forming a luminous corona. In the vicinity of a black hole, a disk of gas and dust often surrounds the singularity, heating up as it spirals inward. This material emits X-rays and other forms of radiation, which can create a glowing corona around the black hole. These observations offer an exciting glimpse into the inner workings of black holes and may help unlock the mysteries of these enigmatic cosmic entities. What do you think about this remarkable discovery? Let us know in the comments section below. If you found this video interesting, don't forget to hit the like button and subscribe to our channel. By subscribing, you'll ensure that you won't miss any future content about the universe's most fascinating phenomena. Thank you for watching, and we'll see you in the next video.